Hello everyone, and welcome back to this next video in the Houdini Academy Foundation module. In this video, we are going to have a look at how we can take FBX files, load them inside of Houdini, give them some materials and collision, and then bring them back into Unreal, either as solid models, such as we have here, or as instances. Now let's have a quick look at that. If I click on my building and I scroll down, you can see that we have a series of outputs here. And some of these are basically for our structure, such as its collision mesh and the main mesh right here. But then down below, we also have a dedicated mesh here that Houdini just generated for the rooftop vents. And in this case, that means that all the vents, basically all the FBX copies that we made, are included in a single model. And in some ways, this is actually quite wasteful. We have quite a lot of triangles here, unnecessarily so. And we can actually make this a lot more efficient. And we can do that by instantiating the copies of these meshes that Houdini just generated. So if I go up to the top of my tool, I can actually switch it over to packed instances mode. If I click on that, then now Houdini is going to generate a single model for every one of our unique objects that we just copied onto our roof. If I look at those, you can see that here we have the small vent, and here's the large vent. And then it has created a dedicated instancer for each of those. So up here we have these instanced mesh components again, the same ones that were used up in this building. But instead of actually grabbing a mesh from our meshes folder over here, we are now actually grabbing it from the temporary folder where Houdini stores its meshes after it's generated them. And if we go ahead and bake out this building by clicking on the building tool and then click on bake, then we can actually bring these out into the actual bake folder of Houdini and use them as whatever mesh we want anywhere inside of the game engine. At that point, they are solid meshes. So I'm going to take you through this process in this video. And other than that, in this lecture, we are also going to look at other necessary information that we'll need to make these fully fledged and properly playable models inside the game engine. Because just having the mesh loaded isn't enough. We also need to make sure it has a material and a collision. So if I click on my tool and I load up its material, in this case, every single one of my models is going to get assigned the material that's located here in the materials folder. Then you can see that we do have a material, and this material corresponds directly to the UVs of our FBX files, so we don't have to worry about that. Then next to that, each one of these actually has a collision as well. And at this moment, we are simply creating a simple collision box. Now, when I'm actually using instances, we cannot properly see the collision on these models because instance collisions aren't properly shown. But if I look at the source models over here, and I look at their collision, then you can see right now these models have a new generated simple collision box. But there's other types of collisions as well, and I'm going to cover all of these inside of this lecture. Now I'll explain more about that later during the lecture. So for now, let's go to Houdini and let's have a quick look at what we'll be building in this lecture today. So here we have the example file, version 1.1 again. And the section that we'll be working on today is located over here. This part up top deals with loading the FBX files, and then it also assigns some materials from our database up here. And next to that, we can also assign either its default collision, which already came with the FBX file itself. If I look at that one, you can see here is the actual collision box that came with the FBX model for this vent. But we can also choose to assign either a simple collision or a UCX collision type. And either one is going to result in a different type of collision suitable for a different kind of purpose inside of Unreal. And then down here, we can take this and in case we are using our own generated meshes, make sure that the collision for each individual mesh is properly assigned for every single unique element. I'll explain more about what that means, but let's first go ahead and set up our basic FBX copying system so we can bring at least some of these FBX models onto our tool in Unreal. Let's go over to our main tool and let's have a look at that. Okay, so let's get started. Down below here, I'm going to take my current visualizer output and let's move this over to the side because I decided that I wanted to build a more in-depth FBX output. So let's create a dedicated netbox for that. I'll make that nice and big. And then I'm going to call this one FBX output. And then in here, we need to start building our loop so we can load our FBX files for every single one of the unique meshes that we're trying to place. Now we already have our current file nodes over here in our dummy setup that we created in the last video. And these file nodes are already retrieving the files that we need, right? So we can actually take these to get started quite quickly. However, I don't just want to take a file node and then switch between one or the other. I want to create a dynamic system that can take any model that's in our database over here and load that in, both with its model and its material information. Now that means that we need to actually provide this path that's currently being provided to our file node to our database over here, and then this gets then sent to the loop that we have to build in order to load the model. So let's do that first. Let's first set up this loop and then we'll update the database to make sure that it can load it. Let's create a for each loop here. Let's make this a for each loop that runs over points. Let's place it up at the top part of this netbox. Somewhere over here, should do. And then I'm going to call this one for each object. Now, in order to retrieve the data that we need, what we're going to do is we're going to run over the instance data that we are currently providing to the instancer output. Because in the end, it's going to be the same point positions. We just have to provide it with slightly different information, such as which model it will need to load in order to work. So let's grab here from our copy to points node and let's pull this over here to the left. I'm going to just create a dot up here with Alt and then plug it into our for each loop. And let's render this one out. And then inside of this loop, we can see that we have currently all of our points. We can set up a single pass and then, show every one of the points in its individual loop. But what I actually want to do is loop over the objects, over the object path, right? And we can do that using the piece attribute up here. If I go ahead and set up a attribute that contains the file path to the file I want to load, and then I feed that attribute in here, it will be a unique file path, meaning that the piece attribute up here is going to loop this loop over every collection of points that is looking for the same file. Now that's what I want to do here. Now in order to achieve that, I first need to go ahead and provide that file path to our points in the database. So every one of our points here, just like how they are looking for their Unreal file path, will look for their actual FBX file path as well. So in order to do that, let's create a new entry inside of our database entries here. Let's name this one s@object. And then, of course, I need to provide another channel string reference. And I'm going to call this one FBX path. So now if I create this spare parameter, we now have an FBX path down here that we can set. We already have the FBX paths over here inside of our dummy files. So if I just go ahead and grab this one, which is the large path for the large file, I can copy that path, go over here and paste it in. Now I am going to set up a slightly more controllable system so we can actually make this work inside of Unreal as well, because Unreal won't have the job folder, won't have the geometry in the same location, right? Because the job folder in Unreal is going to actually point towards the Unreal project folder, which won't have this file at this address. We need to be able to set this manually. But we'll deal with that in a moment, and when we also deal with the materials and such. First, let's go up here, grab this one, and then let's copy it over here as well. So again, as@object object equals channel string reference, FBX path, and then let's paste that in there. So now we should have down here a object attribute, a string attribute, which has the current file path to our actual FBX file. Now, what I can do with that, if I go over here to the left, is run it through my current for each loop. So instead of running it over, like I said, every single point, let's switch this over to the object attribute instead. So this one here. And now if I switch it to a single pass again, the first pass is going to load all these models, and in this case I think I'm still viewing only one type of model. Yes, I'm only viewing large models, so let's just quickly switch this around. So let's say I want to have some more small props over here. And then over here now, I do have a series of points in my one pass, and then I have a different set of points in my other pass. Now if you want to see the actual object path, you can of course go to the info panel, click on the object string attribute, and this should expose that path. It's going to be a bit big on your screen, but at least you can see what each point is trying to spawn. And then here we have the small ones, and here we have the big ones. We're just going to hide this visualizer again. Now, the main reason that we are loading our information over every object is because loading FBX files is actually quite heavy. I mean, loading a single small file like this probably isn't too heavy, but the moment you have a lot of points and you were to run a loading loop for every single point, it basically would mean that that loading loop here would start to load an FBX file for every single point you process, and then for every time you cook or update the tool. And that is pretty wasteful. So it's actually better to do this only for every single file path, and that will at least ensure that your tool isn't going to be looping over and over and over again on the same data. So now that we have each of our points, and they're basically combined together, let's go ahead and set up our little FBX loading loop. So I'm going to create a new null node here. And I'm just going to call this one object. That's going to be the node that we're going to reference data from. Then let's create a file node. Place it over here. This one's going to be our FBX loader. And then let's create a copy to points node, because in the end we do need to copy this FBX file here onto our points. Now let's go ahead and plug this in. So our file node here is going to retrieve data from this object. So let's make an association. If I click on the gear icon on the file loader, add a spare input, and then reference my object, like so. Then now I can add a points expression up here inside of my geometry file. Let's type inside backticks. Because this is a string, and any expression inside of a string needs to be inside backticks to evaluate. And then I'm going to type points. So not point, which is what we've used before, but points. And the points expression requires 3 arguments, unlike the point expression, which needs 4. The first one is going to be the path to retrieve the attribute from. That's going to be -1 in this case, referencing our spare input. Then we're going to type comma and then the point number that we want to grab the number from. Now in this case, all of our points that we're getting from our object here are going to contain the same object. So we can just say 0. And then the last argument is the attribute we want to read. So that's going to be our object attribute for the FBX path. Now, if I middle mouse click on my geometry file over here, you can see the entire file path to the FBX file is right inside of this, and it's dynamic, meaning that currently this file node is loading our small vent. Now again, we are still loading our collision mesh. So just like before, let's go ahead and filter out that collision mesh. Let's create a blast node. Plug it in. Now I'm just going to do this again just to show you once more how to do it. Let's call this one remove UCX collision. And then the data that I want to remove is going to be the name attribute, again, containing our UCX collision. So if we filter out for UCX asterisk, we will filter out every single element here with that name. Let's just type @name equals UCX asterisk. And if we make sure we set this to primitives as well, we should make sure that this should always work. And now we have our pure model. Now it's still too big, so I'm also going to just create a transform node and scale it down. Let's name this one scale mesh. And I'm going to scale its uniform scale down to 0.01. Now whenever you provide an FBX mesh to Unreal, you usually need to make it, I think, in centimeters size. And Houdini reads its files by meters in size by default. So they're going to be way too big the moment you import them. So that's why we need to do this. Now we also need to make sure that in case this file is missing, we don't report an error. We instead just grab no geometry at all, because otherwise our system would break. And then finally, I just want to get rid of a lot of these attributes over here. So let's create an attribute delete node, because at this moment there are just too many attributes present on this mesh, and I don't want that. Let's plug it in behind our blast node over here. I'm gonna call this one remove attributes. And if I go ahead and just delete all of these attributes, the only attributes that I actually want to keep on this model are under the vertex attributes. That's the texture coordinates, the UVs. And in order to exempt that one, we need to add a hat symbol. And then after that, let's also exempt out the normal as well. So the vertex normal in this case. These FBX models have vertex normals, not point normals, which means that they would look better, right? The same thing that we did for our building over here. We created vertex normals for it. And now that we have this, since now it's small enough and clean enough, let's plug it in. Let's hook this up so our model goes into the first input, the geometry to copy. And then the second input comes from the top. So at this moment, if I look at that result, it should now be loading all of our meshes, and it is. So that's good. This is a direct representation of our instances right over here, right? Let me grab this and drag it over, by the way, so we have it right next to the rest. Now, next, let's go ahead and add this to another geometry container on the outside of our network, so we can actually see them on our building. Let's go over here and add a null node. And let's call this one out FBX visualizer. And then outside of our network, at the first level, let's copy our instances geometry container here, because they're all kind of the same in this case. And let's call this one FBX visualizer. Then in here, let's rename this to in FBX. And import our FBX path right there. Okay, so now we have them loaded, and this will also serve as an output to Unreal. We'll still need to clean this up a bit more, but as you can see, we now have our models on our building. They are being represented, and we have a direct idea on what our vents actually look like inside of Houdini. Right, which before we didn't actually have. Before, let me just hide our visualizer here, we only saw our spawn points, but now we have a direct idea on what these look like, and that's always useful. Because we couldn't load them before, like this, we only had our dummy set up, and this actually directly represents the same information, but shown as a dynamic based on the database, instead of this hard-coded method that we were using before. Now, at this point, this system will work in Houdini, but it won't quite work yet in Unreal. And that's simply because our file path is currently hard-coded. We don't have any control over where it originates from. And if someone is going to load this asset into their Unreal scene, the job path that we're currently assigning here is not going to work. It's going to work in our current Houdini scene because our Houdini scene has its project file set, right? But this won't apply in Unreal. So what we need to do is take this first part of the FBX path, $job/geo, which actually leads to the geometry path inside of our project folder. And then we have this folder structure here. And then what I want to do is take this and make it a separate string parameter, a file path parameter on our interface. So we can set this and then have the rest of the file name filled in afterwards, basically added to it. So let's go to the top of the interface, the type properties. And under parameters, let's go down, let's go to setup. And in here, I want to add a new parameter so we can control this part. Let's add a new separator right there below our show visualizer toggle. And then if we scroll up to the top of the list, we will find the option for file directory. This will allow us to select a folder on our hard drive. Okay, let's drag that in. And then in here, the name I'm going to give this is going to be FBX folder. And in this case, I'm just going to use capital letters because FBX, I usually spell it like this. And then this should be like that. Okay. And as for the path itself, I am going to use the $job/geo/ this part. Just feed it in there. And this should ensure at least that if we load our tool inside of our own project folder, it should automatically assign. Now in this case, I'm adding a slash to the end of this because Houdini doesn't care if you have 2 slashes in a file path, it just counts them as 1. But we always need to make sure that if we start to add these together, we don't miss that 1 slash here, right? So if I were to take this part and add it to that, and we wouldn't have that slash, it would look like that, and then our file path wouldn't be correct. That's why I suggest always add an extra slash to your default file path here. Let's apply this. So let's go ahead and open up our parameter panel. Should be over here. And then in your setup folder, you will now find your FBX folder path right here. If you don't have the right path, or you haven't set your defaults correctly, you can always go up here and browse for whatever folder it is that your prefabs folder is located in. Now we can copy this parameter, and then over here in our database, I'm going to select the first part of my FBX path right there, right click, and paste the relative reference. And this will replace the little section that we basically copied out, and replace it with an expression that will automatically be inside backticks, right? So this means that it will automatically evaluate as an expression and not as a string. So whatever comes out of this expression is going to be our file path, and when we look at the result of that, it's going to basically add them together, and after we reach our geometry section here, in this case, because we already had a slash, it's going to add 2 slashes together. Now, like I said, it's better to have 2 slashes than no slashes at all. So let's just go with this. And then let's do the same thing for the small vents as well. So just select the first part right before the slash, and then paste the reference. And that should now work too. So as you can see, we still have our models in the screen. If this wasn't going to work, one of our models would have probably disappeared. In fact, I can show that by simply bypassing one of these. As you can see, it disappeared on me, right? So if this wasn't going to work, it wouldn't be showing up here. So with this, we now have a file path set up so we can make it work in Unreal. Let's quickly have a look here at the end and make sure that whatever we feed to Unreal is going to be clean. We have our object tag, normal, UVs, point position. Now those aren't going to be a problem for us. However, we still have the Unreal Instance attribute over here, but this one only works if you apply it to points, and this is actually a mesh. So none of this is actually going to be a problem for us right now. So let's take this and save out the tool. And let's bring up Unreal. Okay, so let's go over to our foundation tool, re-import that, rebuild. And now, well, we're not actually seeing our models yet, because at this point our file path isn't set up properly, and also we're still seeing our instances. So before I go ahead and bring in our models, let me hide the instances first. Let's disable those. And then under setup, I can browse to where my model files are located. So let's click on this, and I have my file path right here. So over here is the geo folder. Let me copy this, feed that in there, and then I can just select that folder. So now it's loading our models, and they're all white. Okay, so we'll deal with the material in a moment, but we can see we now do have our models, and they are being loaded properly. They are now part of the mesh. If I click on it and I go down, we should now have an output for that. Yeah, here we go. Now you can see that when it outputs a model like this, it won't always be centered. It's going to be located where the pivot point of our tool is located, and our pivot point is located right there. So yeah, it's kind of off to the side, but that's not a big problem because it does match our building, of course. Now let's go back to Houdini, and what I would like to do is just set up a little toggle so we can turn on or off this model output. And then I want to talk about something called geometry packing and packed instances next. Let's go over here. And what I want to do is go over to my parameter interface. And over here under props, I want to change my props output mode so it has two more entries. One is going to be for our FBX meshes, and one is going to be for our FBX instances. So let's first add this one, and then I'll explain what I mean. Let's open up the type properties. And down here under props output mode, let's go down to the menu. And I want to add two more entries here. So the first one is going to be a token of tree, and the value is going to be called FBX copied geometry. And then the second one is going to be a token of 4, and I'm going to call this one FBX packed instances. Okay, so let's apply that. And now I want to set up our instance loader here, so it simply skips the output if it's 3 or 4. So we can just quickly grab from our no instances null and plug this in twice more, like that. Then I'm going to copy this switch, and let's also copy this null node as well. I'm just going to break these connections. Let's drag them over. And down here, where I have my output, I'm just going to plug this in. So our first 3 entries are going to be no FBX. And then the second 2 are going to be this line here. So let's plug that in. Like so. And now, depending on our output mode, we should have control over what is going to be displayed. If I go to the outside of my tool, then in its standard instancing mode, we are going to see our instance points over here, like so. And if I switch it to FBX copy geometry or FBX packed instances, we are simply going to see these. So that's fine. This will work. And then next, let's actually set up the FBX packed instancing system. And this is really easy to do, but it takes a little bit of time to explain. So let's do this first, and then I'll bring you over to some slides to explain to you what this actually is. So let's go back in the tool. And then under our copy to points node, we actually have the ability to pack and instance our data. And if you look under the description here, it says packs the input source geometry into a packed geometry primitive before copying. This results in the input geometry being shared, instanced, by each copy rather than being duplicated for each copy. So, in other words, this is a way for Houdini to take a model, load it into memory, and then instantiate it. So let's first hook this up, and I'll go into a bit more detail after that. Let's copy the prop output mode here, copy that parameter, right click here, paste relative reference under pack and instance, and then I'm going to expand this expression, and in here I'm just going to set it to if our output mode is equal to 4, which is its entry in our parameter interface, then we're going to turn this on, otherwise it's going to be off. So if I accept that, then now, depending on our mode, we're either going to turn on or off our packing system. Okay, so let's bring this over into Unreal and let's have a look at what that actually does, right? Let's save this. reload our tool. And then let's go over to the props tab and let's switch this over to FBX copy geometry first. So here we go. Now we have our FBX meshes, just like how we had before as a solid model. And then next, let's switch it over to the FBX packed instances. And with that, it will have created two models, one for each of our unique models on the roof. And here we can have the small vent. And then here we have the large one. And these meshes are currently being generated as temporary meshes. We can actually locate them inside of the temp folder, like I mentioned. This is where Houdini will store the output of your tool. And then these are being instanced, just like our static meshes before, by a instancer component. Now at this point, we don't actually have our materials yet. So they don't look like the rest of our models here on the roof. And we also don't have a collision, at least not officially. Technically, because of that bug, these models will automatically have been assigned the use complex collision as simple type. So they do have collision right now. If I look at them, they do have collision lines, even though they're very hard to see because this thing is white, right? But the problem is that if this bug wasn't present, these models wouldn't have their collision assigned. So this wouldn't be working. We need to set all this up. And I do want to explain a little bit more about packing first, because packed geometry and how this outputs it to instances actually has a big influence on how collision is generated on these models as well. So for that, I have a couple of slides prepared. Let me load those up. Okay, so let me quickly explain to you what packed primitives actually are. Now down here I have an example. I have a couple of rubber toys here lined up, and each one has its own rotation and its own scale, and it's basically its own entity. It's its own packed primitive. And packed primitives in this case means that they are a method to generate geometry at render time from data in memory. Meaning that every single one of these rubber toys here is actually the same model being instantiated onto these points at render time, or whenever the node evaluates its data, which is visible to other nodes as well. Now this allows it to decrease the amount of memory that's used when it's interacting in Houdini. So in other words, let's say that we have millions of these, and Houdini would probably be able to handle it. Or at the very least, you could render it using, say, Mantra, right? On the other hand, if this was pure geometry, and these were completely unpacked, well, Houdini would probably either chug or just crash right out. So that's one reason why you would want to use packed primitives, just for the optimization of being able to render lots of geometry. Now, when I say that these things act like packages, it basically means that they contain geometry information inside of them. All the points and the primitives are actually still part of the original piece of geometry that's stored in memory. And that information is still there. If we unpack these packed primitives, then Houdini will simply convert all of them back to their original geometry with all the attributes and the groups and all the geometry information intact. But this does mean that a packed primitive, while it's a lightweight reference, cannot actually be edited. You cannot edit the contents of a packed primitive. You can read them out, you can raycast to them, you can find their location, and you can even expose some of their attributes. But on the other hand, it's not possible to sample individual components of these meshes because they're basically just there as an entity. They don't have their individual components exposed. And like I said, if we unpack them, we can then go ahead and re-extract their contents. So we can access that information again. But of course, this does mean that we re-expose all that data, and that means Houdini has to render it. So suddenly all that gain in speed and performance will be gone. Now I'll quickly show you this slide, which is from the help file. And it shows kind of what I mean when I say that it takes a file, stores it in memory, and then if you have copies of that, it's very lightweight. Like if you just have pure copies of this tree here, right? We're basically just duplicating our data. We're duplicating our memory load. Whereas down below here, we have one copy stored in memory, which is one iteration of that memory load. And then all the other ones are very, very small amounts of data, but it doesn't matter. It's very lightweight. And what this basically means for us is that duplicates of packed geometry reference the same data in memory, which practically works the same way as instances do in Unreal. So there's a direct one-to-one comparison there, or at least practically for us, there is a direct one-to-one comparison. And we can go ahead and use that to our advantage. But okay, let's go back to Houdini, and I'll quickly show you what this actually means inside Houdini, right? What it actually means to have a packed primitive. So right now, I have a lot of copied geometry right here, meaning that I have my points available, I have my point numbers, my primitive numbers, and also my attributes as well. Well, in this case, I've removed those, so let me just quickly expose them. Here we go. So now we have a lot of attributes available to us that were actually part of the FBX file, including a lot of point attributes as well. And now let's turn this thing into instances. Let's set this copy to point node over to packed. Suddenly, a lot of the attributes that we had inside of our geometry that we were copying has disappeared. And that's because they are now wrapped inside of these packed pieces of geometry. In fact, if I go over here to my info panel, you can see that right now I have none of that information available. If I pin this and I set it to auto refresh and I turn it back off, and now we have all these attributes available to us again. So all this information basically gets compressed inside of that file in memory. And that means we can't access it until we unpack it, right? Now there's another way how we can go ahead and access this. And that's by creating a pack node. So let me grab up here this little dummy setup. So we have our vent available. Okay, we keep the points exposed. And then let's create a pack node. Now the pack node does the same thing as the pack and instance option right here. And it basically takes whatever geometry you feed it and packs it. And now you can see that all of my points have basically vanished. Also, all of my attributes that were part of this file here, of this FBX file, have also vanished, just like before. And inside of this model, we have a single point, which is a bit hard to spot sometimes, right there, that describes its current location. Now at this point, this pack node is making our pivot located at the centroid, but we can also make it be located at the world origin as well, at which point it will be down below, right there, at the original origin of our mesh. So that's a way to decide where this thing will be copied, because it will be copied to its pivot point, right? And we also have the ability to transfer a couple of attributes from the model itself onto the packed geometry. Let me go ahead and grab, say, one of the attributes here, like the name. And now, if I look over here, you can see that the name attribute is now exposed, but it will only grab it from one point or one element in this geometry. So this is basically just a way to carry some information over to the outside of the packed geometry, as opposed to just keeping it inside of the data. Now, at this moment, what I can do is I can grab a copy node, for example, a copy and transform. And let's set this one up quickly. Let's say I give it a translation of like 400. And then create a couple copies. Now at this point, we have 6 copies available to us. But in reality, what there really are, of course, is 6 instantiations of the data in memory. And over here, we still have all of our attributes available, and they're being duplicated just the same. But now, if I go and unpack this, which we can do with unpack node, we can turn all this data back into meshes. So this is a way to very lightweight copy all that information, decide what we want to keep, and then maybe unpack it, right? Now there's no reason for us to unpack our data right here, but there's other ways we can use unpack as well. For example, if we only want to keep the point information, which is a lot lighter than having hundreds or thousands of models suddenly turn into their full equivalent, we can also unpack to say points. And unpacking the point information is a bit lighter. It exposes all of the point attributes once again, but of course we do lose all the other information, such as our primitive attributes here. Now at this point you know what packed geometry is, and with that we should be prepared to continue on to the next part. So let's get rid of this and let's move on. So at this point, what I want to do is set up our materials. So we can set up the materials on our models and they will work inside of Unreal. Let's go over to our database. And the first thing that I would like to do is provide a path to our materials so we can later load it over here inside of our loop. Now at this point I could add my material assignment right here, but because I want to make this database expandable for if you personally want to add more models, then I suggest you add it inside of these database entries. So for that, let's go ahead and add a new entry here. Let's call this one material for Unreal, and let's reference it to a string, right? So let's say channel string, let's say material path, like so. Expose that. And then we need to actually set our material in here. So for that we can go to Unreal again. And then I want to look for my material inside the materials folder. Over here we have the MHVAC material. We can either grab this or any potential material instances that might be available over here. Let's copy this particular one though. Right click, copy reference. And then inside Houdini, let's paste this in here, like so. So let's copy this, and then let's bring it over to the other one as well. Paste that in. Grab the path. And we're going to plug that in as well. So now we should have all of our points with their materials assigned, like so. And then we can go over to our loop and set this up as well. So inside of our loop here, what I would like to do is copy the point attribute that's currently present on our point. So if I look at the end of the loop, I refresh it, and then inside of this object node, we now have our material for Unreal string attribute available. What I want to do is take this and copy it onto the primitives of our mesh. So this one. And we need to do this inside of the loop because any information that we want to store onto our mesh and for Unreal to take into account needs to actually be provided before we go ahead and copy it to our points. So let's do that. Let's go ahead and create a attribute copy node. Now, unlike the attribute transfer node, the attribute copy node just copies an attribute from one source to another based on its point, primitive, or vertex number, right? So basically, if the numbers match, it will transfer it. And we can also assign this using an attribute. So if we have a piece attribute on both elements, then we can also transfer attributes based on that. So values will only be transferred if the attribute matches between the source and the destination. Now in this case we don't need to use that, we just need to do a straight transfer from one to the other. So let's plug this in. We need to transfer an attribute from our object here to our mesh. And for starters, this is going to be a simple point attribute. So let's set it up. Under here, I'm going to transfer the material for Unreal, which is our material address. But Unreal won't be able to do anything with this. This is just a placeholder name that I'm assigning so that I can transfer it to something else. So let's rename this node to the attribute copy materials for meshes. And this one's going to handle an attribute, so I'm going to color it blue here. And then next we need to transfer it to primitives, so we can assign it to our primitive attributes over here. Let's create a attribute promote node. I'm going to call this one attribute promote material or Unreal material. Because what I want to do with this one is basically take my current point attribute, the material for Unreal, and change it over to a primitive attribute, but then at the same time rename it to Unreal material, all lowercase. Okay. Then this one, let's color this one blue as well. And then I would like to add a switch so I can turn on and off the ability to have my material or not. Because if the material isn't present, then we'll just use the default Houdini engine vertex shader, which mostly represents our colors. So let's add a switch over here. Let's call this one load Unreal materials for FBX. And let's promote that one up to the top level. So open up the type properties here. And then at the bottom, where we have our props, let's drag this in. Let's pull it in right below our props output mode. And I'm also going to add a separator over here as well. Then let's grab this and let's change it into a ordered menu, because I would like to have some text on this one. And I'm going to call this load Unreal material to FBX. And as for the label, let's say FBX material display for Unreal. Okay, that's descriptive enough. And then next, I also want to make sure that this particular parameter that we're adding only appears when we are actually dealing with our FBX copies or FBX packed instances, because I don't need it for our instances or our split instances. So over here, let's go to disable when. So let's copy the name from our props output mode here. And then in here, inside curly brackets, let's say if the props output mode is less than 3, meaning that if it is less than the last 2 entries in this list, it's going to be disabled. Okay, so let's apply that. So let's test it out real quick. Down here in my parameters, now if I have my FBX packed instances set up, it appears right here. But if I go to instances, it grays out. So that works. And then let's go over to the menu tab and let's add the first one as 0. And as for the name, I'm going to say default Houdini engine color material, like so. And then the second one is going to be load Unreal material on FBX Mesh. or meshes. Okay, so with that, if we apply this, then now we should have the option, assuming that our tool is set to FBX mode, to switch between this and the color material right there. Okay, so let's plug this in. And then let's go over to the end of our network. Save out our tool. And let's test it out. So in here, reload, rebuild. And now, assuming it finished cooking, under our props tab, we now have the option to change our material. If I switch this over, then now all of our meshes will get assigned their proper materials, right? Let's look at this one. If I go to the independent instances, they now have a material assigned right here. Okay, so that's working. Now we have the ability to assign a material to these models. But we still need to actually deal with the collision as well, and this one's a little bit more involved. And for that I need to go back to some slides to explain to you the different kinds of collisions that Unreal has and their benefits. But however, this video is already 1 hour long, and I'd like to avoid creating a 2-hour long video if I can help it. So just like last time, let's split this video up, and I will cover the collision system and how to install it into our tool in the next video. So I hope to see you there, and thanks for watching this one. Have a good one.